So let us move on to the converse of the URYSOHN's lemma. For the converse part, we are given that for every pair of disjoint closed sets A and B, we have a continuous function f from x to closed interval 0 1 such that f of A is equal to 0 and f of B, that means image of every point of the set B, is 1. This is given to us, and now we are to show that our function is normal. So we are having, for the normality, we'll start with having two closed sets. So let A, B be two disjoint closed sets. So let these be two disjoint closed sets. This condition is already there because it is given now. We have to find two open sets containing A and B, and the two open sets must be disjoint. So on the line, on the real line, here it is 0, here it is 1. So choose two points alpha and beta here such that alpha is less than beta. Now consider this interval open closed 0 to open alpha, name it as G, and open beta to closed 1, name it as H. This closed 0 to open alpha is sub-basic open set in the topology of closed interval 0 1. Similarly, open beta to closed 1 is also a sub-basic open set. So these are the open sets. These two are open sets. And since the function f is continuous, their inverse images will also be open. So that means f inverse G and f inverse G is equal to this, and f inverse H means f inverse of this are open sets. So these are open sets because G and H were open, so their inverse images are also open because the function is continuous. Now look at your fa is given to be 0. Your fa is given to be 0. That means image of every point of A is 0. But there may be some other points having image 0. So that means A is a subset of f inverse 0. A is a subset of this. Now this singleton set 0 is a subset of closed 0 to open alpha. So that means f inverse of this is a subset of f inverse of closed 0 to open alpha. But closed 0 to open alpha f inverse closed 0 to open alpha is f inverse G. So it is f inverse G. That means your A is a subset of f inverse G, and f inverse G is open. So A is a subset of an open set. Similarly, B is also subset of f inverse H on the same line. So what you will have there? You will have B subset of f inverse 1. Then here you will have beta open to closed 1, and your beta open to closed 1 is this is f inverse H. So what you will have, your B is a subset of f inverse H. So what you are having now, you are having now two closed sets A and B such that A is a subset of f inverse G, f inverse G is open. B is a subset of f inverse H, f inverse H is also open. Now what remains to show that these two are disjoint? For that, f inverse G intersection f inverse H is f inverse G intersection H. So what is G intersection H now? Your G is closed 0 to open alpha, intersection open beta to closed 1. But on the real line, this is your 0 alpha, this is your beta 1, and clearly their intersection is phi. So it is F inverse phi means phi. So for a pair of disjoint closed sets A and B, you have open sets F inverse G and F inverse H, which are also disjoint, F inverse G containing A and F inverse H containing B, which means your topological space is normal. So this is the converse part of the theorem, and we are also proving in the same video the general form of URYSOHN's lemma. So what is the general form? In the general form, instead of having the closed interval 0, 1, we are having any arbitrary closed interval from alpha to beta. So the statement of the general form of the URYSOHN's lemma is X top is normal if and only if for every pair of disjoint closed sets A and B, there exists a continuous function f from x to, now the interval is changing, it is any interval alpha to beta, such that image of every point of A is alpha and image of every point of B is beta. Earlier it was image of every point of A is 0 and image of every point of B is 1. Now it is alpha and beta. So how to prove it? So let us start by taking A and B. So let A and B be disjoint closed sets. So let these be disjoint closed sets. By URYSOHN's lemma, original form, there exists, I'm naming it as G, there exists a continuous function G from x to closed interval 0, 1. It is a continuous function such that G of every point of A is 0 and G of every point of B is 1. It is the original form of URYSOHN's lemma. And now define, let me write capital D, define a function h from closed interval 0, 1 to closed interval alpha beta as h of x is alpha plus beta minus alpha times x. Now look at what will be the image of 0. 0 here, so alpha plus 0 is alpha, so image of 0 will be alpha. And what will be the image of 1? It is alpha plus, this is 1 here, alpha plus beta minus alpha, alpha will be cancelled, so it is beta. Image of 0 is alpha, image of 1 is beta, so it is an onto function, it is an increasing function. It is also a linear function, and since every linear function is continuous, h is continuous. So h is a continuous function. Now consider this function h og, that means G composite h, and I am naming it as f. So f is a function from x to closed interval alpha beta. Since G and H are both continuous, so their composition function f is also continuous. So it is clear that your f is continuous. Now f is continuous function from x to closed interval alpha beta. F is a continuous function from x to alpha beta. Only thing remains to show that f of every point of A is alpha and f of every point of B is beta, and that is very easy. Why? So where to write? Let me rub the top portion because it is just the statement, and now I'll prove the remaining part. F of A. F of A means G composite H of A. That means H of G of A. But what is G of A? G of A, that means G of every point of A is 0. So it is singleton set 0, or you can say H of 0. And what is H of 0 now? You can put a set here, H0. So what is H of 0 now? H of 0 is alpha plus this is 0. So alpha plus 0 is alpha. So it is alpha. Similarly, what is f of b? It is G composite H of b, means H of G of b, but G of b is 1. So H of singleton set 1, or you can say the set H of 1. The set H of 1 is the set H of 1. H of 1 from here is alpha plus beta minus alpha times 1. So it is beta. So what we have obtained, a continuous function f from x to closed interval alpha beta, such that image of every point of A is alpha and image of every point of B is beta, and that was required to be proved. This is the general form of URYSOHN's lemma. In the next video, we will do more and more theorems of normal topological spaces. Thank you once again.